Hi there. Welcome to Tech with Peter Mbanogo. My name is Peter, and this live stream is part of the series focusing on HTTP caching and CDN. And today I've got a special guest who actually is one of the reasons this YouTube channel got started from one of their podcast episodes focusing on how they build their self-purpose CDN. His name is Gerhard, and I'll let him introduce himself because I think he'll do a better job. Over to you, Gerhard.
Thank you, Peter. That makes me very happy hearing that, like that inspiration, how that's like planting that seed and seeing like where you take it makes me so excited. So I appreciate that very much, and I'm very excited to where you take this. Really happy to be part of this. Thank you for inviting me.
Thank you for coming.
So, if I was to introduce myself and if I was like to give like a one-liner, I would say that I'm a software engineer that enjoys telling stories. That is the one line. And because I enjoy telling stories, one thing that goes well with that is sharing my screen. So I'm going to do that now. I'm going to share just a specific window. And this is it. This is the intro. So if you're curious about some of the stories which I tell, um, and these are the stories which I told in the past, you can go to changelog.com. And when you go to changelog.com, you search for Person Gerhard, find my icon, click on it. And I've been doing this for a while. There are about 107 episodes on changelog.com, which I recorded over the years. Um, and yeah, it's all there. So these are like the audio stories, mostly focused on audio. And that's where you can go and find them. Now, if you're curious about the video stories, which I tell, and we'll get there in a minute. By the way, this is the one that I wanted to highlight, the Kaizen 15, not a pipe dream. I think this is like the last one, June. So it's not that long. And we'll be digging a bit deeper into this. But this is like the last story, the audio story, which we told on changelog.com. And that will form the basis for what we'll be talking today. All right. Pipe Dream, changelog.com, it's live, it's working. I did like a couple of changes there. But yeah, we'll come back to that in a minute. And there's like a lot of stuff here. So it's just a matter of following the thread and seeing where it takes you. So yeah, we've been doing this for a while. These have been going years, actually, 3 years it's been. And if you pull on that thread, I guarantee you that you'll find some surprising things, some fun things, even some crazy things, in our past. All right. If you're curious about the video stories, which I tell today, you can go to video.gerhard.io, very simple to remember. And that's a YouTube channel. And these are edited, so they are nice and short, some of them. Some of them need to be longer, and they're longer, but we go into details. For example, we build a modern CI/CD. Like, what does it mean to build a modern CI/CD? I have some talks from various conferences. This was KubeCon 2024. And if you want to listen, if you're more like of a podcast person, pod.gerhard.io, there's a couple of episodes more coming, about one per month. I'm trying to do two per month, but it's not there yet. Lastly, makeitwork.gerhard.io. You can watch the actual videos, the full ones with no ads. By the way, there's a CDN behind this. So if you go and take your curl, take your HTTP stat and have a look around to see how that's put together, I think you'll find some surprising things in that setup. And I'll be covering that soon. The point is, if you don't like YouTube or you don't like the idea, right, of having ads or having, I don't know, a big company own the content, this is like makeitwork.gerhard.io. It's where I host it on a CDN and you get direct access, and the idea is no ads, nothing like that. Anyway, moving on. So one of the things that I've been doing for the last, I think it's 8 years now, is running changelog.com. And the focus is one of the things. And it's been a lot of fun. Now, if you go to the repository, the changelog.com in GitHub, you'll find the infrastructure MD file, which is in that repo. And if you open it up, you'll see a lot of things about the entire changelog infrastructure. This is public. So the changelog.com is a 3-tier monolith. It's an Elixir application. There's a Phoenix framework. and it has a Postgres database. And this basically explains how all those pieces fit together: search, secrets, even some instructions of how to set things up. The thing which I would like to highlight is this diagram. There's a lot of detail in this diagram. Tip, click on that link, and this will take you to mermaid.live, where you can zoom the diagram, which is exactly what we're doing now, so that we have a better understanding of the various components. There's a lot of stuff that runs on fly.io, and this is what that looks like. This is for the changelog app. This is GitHub, where we started. Again, a lot of things running in GitHub and also connecting to a lot of other things. There's BetaStack, which monitors uptime. And then there's Fastly, Cloudflare R2, and AWS S3. We'll come back to in a minute, Neon.tech. So Fastly and Cloudflare R2, but specifically Fastly, the CDN part, that's what we'll be focusing on today. So just to put things into context, that's the little piece that we will dig into. I'm looking at Peter, just in case you have a question or if you have any ideas, because I went a bit fast to begin with, but it's morning, so I'm full on.
Yeah, that was quite impressive and a lot of info. And for those listening or those that would listen later, I know you mentioned Kaizen episode on the
Mm-hmm.
podcast, and I just want to take them back as to what you meant by the pipe dream. So I think they were a series of pull requests and discussion
Yeah.
on the Changelog podcast where you are experimenting with different CDNs, trying to optimize for specific things.
Mm-hmm.
And then I'm curious why. Maybe you'll come to this later. I'm not sure, but like what you started, um, why you started going down that pipe dream way,
Okay.
and how you, just to give the listeners some info about this video.
Yeah. So I'm going to cover it in about maybe 5 to 10 minutes, and we will dig into that a little bit more.
Okay.
In a nutshell, we've been using Fastly as our CDN for I think 6 years now, 8 years. No, it's actually 8 years. We've been using Fastly as the CDN for Changelog.com for 8 years. And that journey taught us so much. And we reached a point where we're thinking that we need to build a small single purpose CDN for a certain part of the changelog. The reason is, and again, I'll get to that in a minute, I'll expand on it in a minute, but in a nutshell, it's complexity, right?
Yeah.
With when you deal with a big system, we maybe use 1% of it, so we don't need all of that, and it's there whether you want it or not. And the other thing is, I think our infrastructure doesn't change that much, right? Like once we took it through a couple of big changes, but now it's like fairly mature. We've been doing this for a bunch of years, and we settle on something that works really, really well, that's simple, and that everyone knows. The team is small. We don't have a lot of time to be spending on this, and the simplicity is what is driving these things. And you may be wondering why or how. We'll get to that in a minute. So I think I would like us to take a step back and think about a CDN. And this is a site which is familiar to Peter, right? Why? Because he's based in Germany, right? And in Germany, they have this wonderful thing called the Autobahn. And it's amazing. It's an amazing piece of road where amazing cars can do amazing things. To me, the CDN is this road on which apps of all types and shapes and sizes have to run on. And in the context of a CDN, we care about two things. One, or at least I care about two things: speed. Regardless where the user is in the world, it has to be fast. And really, this is just like another facet of latency. The latency has to be low, right? I think that's even more important than raw throughput. And the second one is resiliency. So CDN can be great, that's fine, but it should not fail, right? One of the reasons why you have a CDN is that because you want to be up and available. And when everything looks great, as you can see, this like wonderful piece of road, everything is simple, there's no cars, amazing cars can do amazing things. And really you need solid engineering. And it's a type of engineering that, the best cars use, and the best systems used in the world, whether it's a road network, whether it's like a rail network. Um, so that's, I think, a requirement. Unlike high performance cars, no one will die if the CDN fails. And this is important because we may be inconvenienced. Some people may rage on social media because their artificial dopamine flow is interrupted, but otherwise, it's no big deal, right? If something doesn't work, um, compared to a tire blowing up at this speed, which is 250 miles per hour, right? If a tire blows up, that's it. It's like game over. So, it's the stakes aren't as high, but they are important. All right. I would like to, again, bring us closer to the CDN and bring us closer to the changelog story and look at the history that the CDN role or the CDN components play the changelog. And this started in 2016 when we introduced cdn.changelog.com, which was hosted by Fastly, run by Fastly, and we have been using it ever since. This part worked really, really well. And even to this day, it works really, really well. So this is the part that it's very good. Like nothing to say there. In 2021, we basically put the CDN in front of the website so that certain pages which are static can be cached better. And this is where some of the problems started. One of the problem, which we talked in July 2nd, 2021, there was a big outage, and this affected a lot of websites. It was a big Fastly outage. It affected BBC, it affected New York Times, it affected The Guardian, it affected a lot of media companies. Changelog was one of them. This was July 2nd when we recorded this. You can go and listen to that episode. It's basically the first Kaizen that we've done, which is shipit.show/10. That's the easiest way to get to it. All right. Then in 2022, we went up a gear. And what we did, we started moving the static assets. We were using block storage until that date. And we moved it to S3. It was a fairly simple migration because there wasn't like many moving components. It was like literally like a lift and shift. We've done it gradually. We were doing like testing for a while, and we've approached everything this way. So at some point, there was both block storage. The assets were on block storage and on S3, on object storage, and everything was fine. We confirmed the latency. And because we had the CDN in front, this was like very little disruption. In 2023, what we've done, we've moved from S3 to Cloudflare R2. And the reason why we did this is just a cost-saving exercise. As you know, S3 will charge for egress fees. So when something is being served from S3 to like an outgoing endpoint, and in that case, that was Fastly. So any transfer between S3 and Fastly was being charged. Now, even though the CDN, like the cache hit ratio was good and things were like fairly well optimized, we were still paying more than we needed to. It just has to do with like how much data changelog.com transfers. And just to give you an idea, I think even then it was more than a terabyte a day. So a lot of data is being transferred, basically. Yeah. R2 egress is free, right? So I think we saved, and we talked about this, by the way. All this is public. It's like in those Kaizens. You can go and check it out, dig into more details.
So these are all like the audio files, the video files, not just the website static assets.
Correct. Yes, the audio files. So there's no video files that are served from the changelog.com directly or the CDN, but there's a lot of audio, like 10 years plus worth of audio across many different shows. We're talking, I think at this point, it's hundreds of gigabytes. So it's not that much, but this gets transferred a lot. Like this content gets pulled a lot from all over the world. And I think this is something which is important because to have a CDN, you need to have traffic which is global. And in our case, it is, right? All the way from Australia to the Americas, South America, North America, Europe, Asia, pretty much everywhere. Africa, there's like, again, a lot of data being transferred, and you want to be close to those users because not everyone has the connections that we have in Europe or America, by the way. This is especially important, in other uh, countries. Okay. The last thing which happened, this was a big one, our feeds, which basically all the various podcast aggregators and distributors like Apple Podcasts, Spotify, Overcast, there's quite a few. They basically ingest and then distribute. Um, we moved this from being served by the app because they're fairly static, right? I mean, they do change maybe once, twice, three. Actually, now that I think of it, they change maybe once a day, twice a day. It used to be maybe once a day before, but now it's a bit more. The point is, these are static files, very large files, which cache very well. And we did a migration from serving it from the web app to putting them on Cloudflare R2 and then serving them from there. And this basically made them a lot more reliable to begin with, but also a lot faster. Reduce resources on the app, like generating big XML files takes a while, right? Some are 10 megabytes, 8 megabytes, whatever. They vary in size. So that takes a while. Lastly, and this is where we are today, the pipe dream. That's in 2024, which started. And another thing which is on the list is Tigris object storage. Now, we'll only be talking about the pipe dream today, what it means, what it is. Tigris is more like an idea that's up and coming. So, why do we start building a CDN for changelog.com? This is a question which I have. But before I answer that, Peter, anything else you would like to ask?
Yeah, I wanted to point out, you went through a lot of nice information regarding why you use CDN and the history of how you've used CDN for different parts of the website. And you mentioned speed,
Mm-hmm.
resiliency, and latency, and I think those are what a few people underestimate. And I just want to say, for those that have not seen the previous episodes of this live stream series, I think in the first one we had Andrew from Assistive Lab. He talked about the experience with Apple product launch, where they use the CDN to be able to improve the speed of one of the products they were going to launch at Apple in 2014, I think. And but then what comes in mind was the resiliency and the latency, because you did that to be able to get low latency, but the resilience part came in where they misconfigured the CDN, and then they were calling fastly like every millisecond, because then each user was kind of getting their own unique cache object because of the URL, which is
Yeah.
what the CDNs use. So at that point, Fastly was getting a lot of traffic, and then the availability was going lower. I think they went from 99% to down to 97 for Akamai. Akamai? Yeah, I think it was Akamai.
Mm.
And then they were also having issues with the S3 bucket. So those S3 object storage and CDN, they help to reduce. Um, they can scale very fast and to handle more traffic. And then the speed part, talking about the caching. Last week I also had Robin from Akamai talking about the history of CDNs and how initially it was about trying to reach more users around different parts of the world. So people had, instead of each e-commerce store, for example, having their own data centers and trying to have redundant servers, the CDNs would acquire more servers and equip them with tools and ways to be able to, handle this traffic and scale to handle much more load for them. And these are quite impressive. So if you are curious to learn more about how those work, check the previous episode. And yeah, that was just what I wanted to point on. So you can carry on.
Yeah. Yeah, that's right. Uh, CDNs are a wonderful tool. I have to say, they make a lot of things easier, but also it takes a while to learn them and to understand what the limits are. Every system has limits. Even the Autobahn has limits. The idea is like make sure you know what they are, road conditions, all of that. Same thing for CDN. And the more you use it, the more you discover those limits, and you have to stay within the boundaries. In our case, the reason why we started building a CDN, which is just for changelog, it was something which even to this day, it's hard for us to explain. And we have tried from different angles. Basically, things should be cached, and they're not. So as you can see on this graph, you can see the cache hit ratio. The goal will be to keep it around 90% or even above 90%, so that most of the content, like 90% plus, 95, 99 would be ideal, is always served from cache. And as you can see, this is basically the cache hit ratio for the entire year, entire 2024. We're looking at 8 months. And you can see that until about March, things have been fairly stable. That's around between, like, the dips are, they go as low as maybe 70%, but it's usually around 80%. Not great, but okay. And you can see, like, those, the vertical lines is when config changes happen. So what's happening after March is interesting because there was no config change for about a month, right? At that, like, middle vertical line. And then you can start seeing the cache hit ratio going down as low as 30%. And that is bad because it means that the CDN is not doing its job. And it doesn't matter why, it's just not doing its job. And then you can see how it starts going up again and then down again. And you can see there towards, for example, the first half of June, it was the highest it's ever been, right? You can see like that very high dip over, very high peak over there. Nothing changed. It's just like how the system chose to cache, how the system chose to behave. On our application side, not much change when it comes to caching, right? It's like fairly static. And then you can start seeing like the dip again. So this pattern is very difficult to understand why it's happening. But what we do see is that users are waiting, right? They're waiting for things to load. And it's not great, but it's okay. I mean, people can wait, I think, a few seconds, sometimes even longer. So it's okay. It's not a problem. What is a problem is when things go offline. Like, this is pretty bad. What it means is that if the CDN cannot serve content from its cache, that resource will appear offline, especially if the backend system is struggling. The reason why we have a CDN is, for example, when something goes wrong on the backend, you have some stale content to serve. If that is not happening, you're offline. As simple as that.
Yeah,
So,
I
yeah,
thought the CDNs are supposed to always serve the stale content anyway, but if they've been evicted from the cache, there's
exactly.
nothing.
Exactly. So you think, hey, maybe you've misconfigured this. Well, we have been looking at this for years. It's not like something that's been like weeks or months in the making. We have been looking at the docs. We have been talking to support. We have been like doing various things. And the truth is, the system is complex, really, really complex. If you're not using Kubernetes, or if you're afraid of Kubernetes, I can guarantee you that that is not as complex as a big CDN, right? And you don't even have the visibility into it, like full visibility, because it's just massive, and no one does. The system is too big, right? It's physically impossible to have the time to understand how all the components interact, what all the components are. And there's various reasons why you wouldn't even do that, like regulatory reasons, security reasons, lots of stuff. So you will never be able to have that visibility into a system that you don't own, and into a system that it serves many, many various use cases. Those are very valuable systems and important systems. But in our case, this is how the pipe dream started. This is the very beginning of it. It was January 2024, earlier this year. And this is Gerhard. We were talking in the Kaizen. And this is what he was saying. He says that he likes the idea of having this 20-line varnish config that we deploy around the world. And it's like, look at our CDN. It's simple. It can do exactly what we want and nothing more. And he agreed that it could be a pipe dream. I understand that it's a pipe dream because the varnish config will be slightly longer than 20 lines, and it would run into all sorts of issues that we end up sinking all kinds of time into. So he had some insight there, but let's see how that played out, right? That's the point of this. So if you want to basically go into more detail, right, like to have the context around this excerpt, changelog.com, changelog and friends, episode 38. change.com/friends/38. And this is where you'll see the details, right? It's the transcript. You don't have to listen to it. If you prefer to read, you can read. So this is how it started. This was the beginning of it. Now, I think in the description, Peter, you said that we finished building the CDN. How did we build it? We haven't finished yet, right? We're still building it. Just to be clear,
Sorry,
and
guys.
yeah, that's okay. That's okay. Small correction. We haven't finished yet, but we are very much in the middle of it, and that's good news because it means you can join this adventure. So, where are we at today? And I'm going to switch my screen share, but this is a good point to maybe unpack anything we've discussed so far.
Yeah, I think you. It's quite impressive how you folks at the changelog monitored the cache hit ratio, because throughout the entirety of the period I've used the CDN, I never bothered to check
Yeah.
the cache hit ratio. I just expect, okay, it's a CDN, it's fast, and Cloudflare give me a free one, so let's just use it. But
Yep.
I think it's quite interesting if we monitor this. Maybe we are actually not getting the promised value, like in terms of the number of cache hit ratio we could get for it, because you showed how it fluctuates, And did anyone from Fastly give any insight as to why this might be happening? Maybe some infrastructure problem?
So, by the way, that graph was taken from Fastly itself. So they have an
Okay.
excellent observability section. They give a lot of detail. It's really, really good. I mean, what I've showed is maybe it's not. I wouldn't say it's not even 1% of what is available in the Fastly dashboard regarding how the cache is behaving and how the requests are being served all over the world. What's more, we are integrating the Fastly logs directly into honeycomb.io. So every single request that Fastly serves, we see it in Honeycomb and we can slice it and dice it. And the two put together are amazing. They give us so much insight. I think that's one of the main reasons why we are so aware of what's happening is because first of all, we can see it in Fastly in great detail. Second of all, we can take the raw data and slice it and dice it in so many ways very, very easily so we can understand when certain endpoints aren't behaving correctly, when certain data centers like Fastly data centers or POPs are misbehaving, when different clients maybe misbehave, because that's sometimes the case. For example, if you're loading a podcast from your Apple Watch, it will be slow. It has nothing to do with the network. It has more to do with the device that you're loading the podcast on. Being able to drill down into that without Honeycomb and without like the integration which we have, it would be very difficult. Possible, but very difficult. So to answer your second question, like if Fastly has been helping, yes, they have. They've been very helpful. But again, back to my first point, the system is really complex, right? We are one of many thousands, tens of thousands, hundreds, I don't know how many, but we're one like many, many users that Fastly has. And in our case, something isn't quite working in some cases, not always. You can see the graph is not always like consistently bad or
Yes.
consistently good. It's very, I wouldn't even call it seasonal. Sometimes it goes down, sometimes it goes up. And because things are changing all the time in complex system, it's really difficult to, I mean, the system never stands still, right?
Yeah.
If you had a complex website or a complex series of services, you're always deploying something, you're always upgrading something, configuration changes all the time. There's so much stuff happening.
Yeah. I just now I was thinking one of the issues might be, it's a very massive system shared by all. So maybe, the more data they have to store in the cache, they evict
Exactly.
some users that, if you don't get frequent users for a period of time, and then when you now have your influx of users, then there's nothing to cache from.
Exactly. That is again one of the high assumptions and hypotheses. Can you test them? Because the system is changing every minute. There's no point where you can say, okay, what's happening now and what's happening now and what's happening now, because the system adapts, as you mentioned, based on the requirements, based on different traffic levels, based on so many factors. There's like a very complex algorithm in the middle of all of this. So I think it's just a scale problem. It's really, really big. And what would be the value? Let's think about that. What would be the value of one very small customer, Like
Yeah.
we don't own the CDN. That's like the whole point. It's a shared resource, right? So you get like the best that you can, but there are certain guarantees that have to be upheld. And we get that. And I get that. So it's a well-designed system. Nothing against it.
Or maybe they sell you an enterprise version for 120K, yeah? Maybe you just have a small slice of the POPs, you know?
Everything is possible. It really like this is basically being honest about a really hard problem
Yeah.
and accepting the reality for what it is rather than trying to complain about it, trying to change it, or trying to, I don't know, be disruptive or greedy. It's a shared resource. We get what we get, right? It's a good system. What are we missing so that our CDN experience is better? Which is why the pipe dream, it just takes a small slice of our CDN, especially the application side. So, how can we get our application requests cached in a way that is different from how proper static files are cached, like those MP3s or those JavaScript files or CSS files or image files? Now, that doesn't mean that one day we may not run all of it for ourselves. But right now, we're taking a very small slice of the problem and we want to see how far we can take it, which is what the pipe dream is. Now, in preparation for today, what I did, let me share the screen. Let me move this. Can you see that? My entire screen?
Yes.
Okay. So on GitHub, if you go to github.com, the changelog pipe dream, it's a public repository which has everything that we've done so far in the context of the pipe dream. There's really only one commit, really, really simple. And the starting point would be the README. So the purpose of this repository and the purpose of the pipe dream is to have a single purpose, single tenant CDN for changelog.com. We are running Varnish Cache, the open source variant, on flat.io. Those are the two components. And this repository exists for one reason only, to build a simplest CDN on flat.io. And we think that this may be helpful for others, which is why we split it from the changelog app and we've put it like in its own standalone repository so others can use it, others can maybe learn from it, and even contribute if they so choose. We've already seen the excerpt, right? If you click here, it takes you directly to the transcript, which I mentioned above, and you can also go to the top right and just like hit play and listen to the whole thing, right? It's an hour and 20 minutes, so it'll be fun. Now, coming back to the repository, we did two things so far. So we configured the static backend. We are serving requests. They can be stale up to 1 day. They'll be fetched in the background. We, when there's an error with the backend, we are able to serve stale requests, and we're using X headers. All of this in 46 lines of VCL. So all of this is implemented in 46 lines of Varnish configuration language. The second part, which is where we are currently, we are changing the static backends to dynamic. And the reason why we're doing this is because when the application updates, there's new IPs the application gets. You need to use the DNS to resolve them. Now, there's a gotcha there because these IPs, they're IPv6s. There's always like a new IPv6. And something in the healthiness probes is not working. This is Varnish healthiness probes, and we'll get to that in a minute. We are using the new cache status header. By the way, I haven't known this. James, one of the contributors, James A. Rosen, he mentioned this to me. X-headers have been deprecated since 2014, I believe. Right, so you shouldn't be using them. I didn't know that myself, so I've learned, and we'll see where that is in a minute.
Just in the context of CDN or
anything. So, okay, let's do this. This initial commit, right? There's quite a lot of detail here, which I highly recommend looking at it. The idea is like there's quite a few, like all the context is captured in commit messages. So they're good commit messages, right? And it's mentioned here how you can help, like different ways you can contribute, but we'll come back to that in a minute. So let's see. This pull request, let me go to GitHub changelog.com. Let's go to pull request. This is how that started. James, okay, this is when we start. This is June 21st. This has a lot more detail. This is a lot more detail, by the way. The video, the demo, we'll come back to this in a minute. What I want to mention is this conversation, which is super valuable. Okay. So this conversation, we were looking at various aspects of the initial config, the first one, which was committed, and we're trying to do improvements to it. So here I just want to, because we talked about the headers themselves, there you go. It's perfectly fine to use, but this practice was deprecated in 2012, correction. So let's click on this to see when this was deprecated. We're going to Mozilla. HTTP headers, let the client know. And if we look at X dash, custom proprietary headers have historically been used with an X dash prefix, but this convention was deprecated in June 2012 because of the inconveniences it caused when non-standard fields became standard in the RFC. And there's the YANA HTTP field name registry, which I would highly recommend checking it out. So coming back to the pull request where we were, I looked at the various headers, and the one, like this is very, very helpful, by the way, this like all the various headers which are supported, cache status was the one that was coming closest to what we needed. You can see I have the CDN cache control, CDN loop, and they all have explanations. So again, if you're into like building CDNs, or if you're like interested in like HTTP headers and the HTTP protocol itself, this is a great resource, especially for the headers part.
Can you share the link?
Yeah, sure, I can share the link. Actually, sure, let me share this link first. Let me drop it in the chat. There you go. But also, I think the context is always, I am a stiffler for context. I think that's really, really important. So I'm going to share this pull request because the conversation is really, really valuable. And this will take you an easy hour to just get through. So it's a great reading. And again, it's something that's happening organically. People that are passionate about this sort of topic, and they want to come together. So that's all that we're seeing in this pull request. Now, we created a separate repository where we can just focus on this and make an abstraction from like the entire changelog infrastructure, which, as I mentioned earlier, it's very broad, right? So we're just focusing on that one small piece. Cool. So this is where the head is mentioned. Anyway, coming back to, if I come, actually, you know what? Let's just keep that open. But I want to come back here because I have a pull request, and the pull request basically does like the second part. And this was very recent, right? So we did this on August the 2nd with James and Matt, right? We did this, we recorded it. When it will be public, I'll share the link. And it's a follow-up to that pull request, like that conversation, like we took it further. And we did a couple of changes. First of all, we did dynamic backends, and this doesn't fully work yet, so we'll look into that in a minute. But also, we're placing the instance, the initial instance is on flow.io. We're placing it closer to the origin, which is the application backend itself, right? And that could maybe become a shield one day, like a CDN shield, where the other CDN instances, they will just feed off the shield rather than hitting the app. Maybe it's an idea. Also, we changed the X cache header and we replaced it with cache status. Couple more things, but this pull request one in the pipe dream, and again, I can drop this link. If anyone watching this is interested to follow this story, this is a good place to do it. So I'm going to send that link as well. I just shared it with you, Peter. Cool.
Yeah, I'm dropping in the chat.
Right. So, and if we look at the changes, there's really not that much, right? It's like fairly simple stuff because we're like taking a thoughtful, slow, deliberate approach because we want to understand everything that we do. We want to keep it simple, and we don't want to add anything extra that we don't need. Okay. So I have something else here local. This is still my main branch checked out. And in the context of the main branch, and I mentioned this in not in this pull request, but in the other one. So not pull request one on the pipe dream. I mentioned it in this pull request 518. This is on the changelog.com. So what we'll be doing, we'll be running this run, right, to see how that behaves, what's there, because it's fun. That's why. All right. Run is just a script, right? You can think of it as an executable, which makes a couple of things interesting. Okay, it just makes it easy. Just run some commands. It has some formatting around it, so it's easier to understand what is happening. So What do you think, Peter, about running this and seeing what happens behind the scenes?
Yeah, we can do that. I'm just checking on the chat if anyone had questions so far, but I see no questions
Mhm.
at the moment. But it was quite interesting, you know. I when you mentioned the headers, I didn't know about the. I know I've used some like X authentication, X stuff in the past, but I thought the cache status header was like a common thing because now using Cloudflare, you know, they have this CF cache status. But I've been also reading recently, you know, after going a bit
Yeah,
into the CDN, the RFC. So I was reading the RFC 911. So I think it's like it's just dedicated to the HTTP caching, and I'm not sure if it was in that um, standard or if it was the other one. I think there's this 7234 where they also
Mhm.
introduced this cache status header. And I mean, if you're building CDNs, then I think you know you might need to go deeper
Yeah,
into the RFCs or some kind of caching layer.
I
Otherwise, I
think so.
think
Yeah,
maybe MDN has some info on the specific headers you can just check and
yeah.
use. But so now the run would it deploy something on fly.io or what would it do?
So we'll see, right? If we do the demo, this one, so I'm going to
Okay.
run through this one, and it will tell us what it does.
Okay.
So the first thing we see 1 out of 7, step 1 out of 7 steps. And in the first one, it tells us what commands are available, what sub commands are available to the run script, run executable. That's how I think of it, because I don't think it will be a script forever. For now, it is. You can think of it as an executable. So you can try it out, right? Local, and I even mentioned in the pull request how you can. How sorry, not in the pull request, in the commit. If I go um, to this one, let me go back to actually the pipe dream. And in the commit, the most is the run script. To run it, you will need a couple of steps, right? This is what you need to do to be able to run it yourself. And if you want to try it out, Peter, not now, maybe afterwards. If something doesn't work, I'm very keen to see your pull request or even issue. Doesn't matter, whatever's easiest. Cool. So to move on, the first thing that we do is we are running HTTP stat, which is an amazing utility. It's a Go utility, by the way. It's just a binary. We're running HTTP stat on the pipedream changelog.com. This is configured to point to that fly instance, which is the varnish config configured to proxy request to changelog.com. And you can see that in this case, we're still using the X headers, right? XTTL, XGrace, XCache, and XCache hits. So what you see here is that the TTL has 46 seconds left before this will be considered stale. The grace period will be serving it up to 1 day, and it will be fetching the request in the background varnish for us. It will serve a stale request. Was it a cache hit or a cache miss in this case, or stale? By the way, we added stale as well. And how many times was it served from cache? All these we can see via this header. The important thing here is the total time. DNS lookup was 14 seconds, TCP connections 14 milliseconds, 4 milliseconds, TLS handshake. Server processing is a bit high, 151, but the content transfer, and we'll see why this is so high, the total time was 362 milliseconds. For CDN, this is slow. Honestly, anything
But
above.
this,
Mhm.
I've got a question about the server process. Is it the server processing in the Vanish server or in the actual origin?
uh, Server processing, if it needs to go to the origin, if it's not in the cache, it will include that time as well,
Okay.
right? Because whatever Varnish needs to do to serve the request, including going to the origin, if it's not in the cache, would be in the server processing. So yeah,
Okay.
it's whatever Varnish needs to do before it can serve the request. But the content transfer is really high, 186 milliseconds. This tells me that the instance is not close to me. There's no POP which is close to me that can serve this. And the way this is only configured to serve from, there's only one instance running, which is close to the application origin, which is exactly what you don't want. The reason why you have a CDN is so you can distribute it as wide as possible, so it's closest to where the users are. Cool. So the next thing which we're going to do, we're going to scale this instance across the entire world. And I'm going to say yes, and it will do the execution plan. If this was not possible, it would make the entire endeavor futile. Because this is so, like, it took seconds. This was not recorded. This is live. I scale this instance across the whole world using Fly in seconds. It's running in Sydney. It's running in Singapore. It's running in Japan. It's running in Johannesburg. It's running everywhere in the world. And again, having this technology makes this possible and makes it simple. So how many dollars do you think this costs us per month, Peter, to scale across 16 regions or 16 points of presence, shall I say?
What's the machine size?
The default one, which is shared one CPU and 256 megabytes of RAM. The smallest Fly instance.
Okay, I know a bit of flight, so I'm just guessing maybe 50 to $100.
Per month, it costs $1.94. You have 16, $31. Now, that doesn't account for traffic, and we're not using any storage. So this is just the compute cost itself. $31, 16 regions, not bad. Or sorry, 16 points of presence, shall I say. 16, I mean, Fly calls them regions, which is why I call them regions. But, you know, for those that know AWS or GCP, a region isn't really data center. It's a bit more than that. It's like a series of data centers. But anyway, I'm just digressing now. So what about now? Is this better or worse?
This is worse.
Why do you think it's worse?
We had 361
Yep.
total, but we have a lower DNS lookup, lower TCP connection.
Yep.
Server processing is higher than before.
Correct. Yes. And?
Oh, it's a cache miss. Okay.
Yeah. So I'm connecting to the instance which is closest to me. That's why everything is like, especially the TCP connection is lower.
Oh, okay.
Right. So it's like, this is like in London Heathrow. That's the instance which is closest to me. However, that cache instance has to go all the way to Ashburn, Virginia to fill the cache, which is why things are slower. Now, what happens if I run the same command? I'm going to open a new window. I'm going to run it again. Is this better or worse?
Way much better.
27 milliseconds, 20 times better. Now, it is stale, right? We can definitely see stale, but look at the TTL. So when we've hit it first, it was a miss. So it had to go to the origin to fill the cache. It filled the cache. And the second time we did the request, it was 60 seconds later, right? Just over, like 61 seconds later, which means that we got the stale content while Varnish went in the background to fill the request from the origin. And that's why it was 27 seconds, really, really fast. So I'm wondering what happens if we do a speed test. So this is OHA, OHA. It's a tool that's it's a Rust-based CLI, and what we're seeing here, we're sending one request every second to this app, and it's showing us the distribution of the response time histogram and how many requests it sent. So once it hits 30 requests, it will stop. We're almost there. 25, 26. We can see the bar at the top. It's almost finished. Boom. And when you look at the distribution of the requests, we can see that 28 of them were served in 33 milliseconds. And I think this is good. This is exactly what we want.
And you had one with 7 milliseconds.
Right. So I've noticed that this tool always does that. You always have a really fast one, which is impossibly fast, and you always have a really slow one. And I don't know, I think that has something to do with the tool, because if you were, for example, to run it any other way, you would see it consistent. So for example, let's put an H watch on this, and let's run this every second. Actually, every 2 seconds. That's what it does, that every 2 seconds by default. So you can see that it's consistently 26, right? And if I go back in time, 25, 26, 20, this one, the first one is slightly slower, 72. I'm not sure why it was slightly slower, but then all the subsequent ones, they're like within 26, 27. So, and even this one, 72, what did we get here? This is 269. This is too high. The first one would not be that slow, right? And you can see all the requests are like within 26, 27. This one is 104. Interesting. Did I see
But
that right? No, this one is
it,
104. Yeah. So if we keep running this, I'm yet to see one which is above 100. And in this case, it's a hit. I'm not sure why this one's slightly slower, to be honest. Let's see. Do we see anything that takes more than that? No.
but this
100
is one
milliseconds.
request per second, right?
This is one request every 2 seconds by default. Let's see if we can increase the. There's a way to increase, not the interval.
I
I think
think
it's plus.
I
Yeah,
think for OHA, I think what it does is like it runs sends maybe, let's say, maybe 50 or 100 traffic requests at the same time. Depends on how you configured it, and
yeah.
some concurrent. So
It's
probably
it's
when your
configured this
server.
way. One every second. So this is configured to send only one
Okay,
request
so just
every
one
second.
request.
Yeah.
Okay.
I'm going to drop it in the chat, by the way, this command, just in case you want to run it. But it's there. So anyway, if we look at this again, they're mostly within, I think there's like a few ones, like this one was like 100 and this one was 70, but none that were below 26. So that's why like that really low one makes me think there's like something else going on here. Anyway, just to move on, we're going to run this again. We're going to run this again against changelog.com, right? Which is like served by Fastly, so like what everyone goes to. Before we were running against Pipedream, now we're running against changelog.com itself. And what this does, this will basically go through the Fastly network. 21, 22, we're almost there. 27. You can see the distribution again. Let's see how this looks. Cool. So you see, you have something very, very similar happening here. You have one which is really slow, which took 3 milliseconds, and one which is really fast. And again, this is consistent across runs, which makes me suspect that something funky is happening with those. So really what I pay attention to is this one, right? Like the majority of the requests, or if there's like any distribution in between. So 48 milliseconds. 48 milliseconds is slower than the 27, 28 that we were getting with Varnish. Cool. So I think that's like an interesting observation. How many lines of
And,
Varnish config? This is all of it,
and
right?
I just
Yep.
wanted to mention that, and this is 16 regions, which Fastly as a CDN should have like maybe 200 or more
Yeah,
CDNs.
exactly.
So it should be that
Yeah.
they are even much faster to reach.
Yeah. In theory. In practice, we've seen a different thing.
Yeah.
Cool. So this is like, this is all of it. This is all 46 lines that makes that possible, right? And it's all like in that repo in the pipe stream. You can go and check it out. We won't be going through this. We only have about 5 minutes left. So there's one more thing which I'd like to cover. And that's it. That was like the demo part. Cool. So this is the Pipedream app, right? You can see like all the files. There's like everything that we use, the fly toml, right? This will be familiar to you, Peter, because you've used fly.io, so you know how that works roughly. The regions, this are like all the regions which I mentioned. We picked 16 out of these. There's 36 in total. The default VCL, right? There's quite a few comments there and links. I think that's what makes it more interesting for people to see if they want to see it. The run script itself, just to see how it's put together, what it does, I would say it's fairly straightforward, just basically functions. It's very functional. And yeah, the README is not interesting because you've seen it already. Cool. So the next thing that we have here is the dynamic backend. I think this is a bit more interesting. So let's just check that out and let's see how the varnish changes in this case. That's what I want. Okay, so we have dynamic. That's an important one. We have the healthiness probes, and I would like you to pay attention to this because this will be important in a few minutes. We have the dynamic director, right, where we basically configure dynamic series of backends, the TTL, we have the probe, the first byte timeout, all that stuff. We have the VCL requests. I mean, this is very similar to what we had before, including a varnish status. We have the backend, which is the fly application, right? And this will be internal. It runs via the internal 6PN network, IPv6 private internal network within Fly. So we don't go outside of Fly when Varnish connects to the origin. And this is important. Then we set the host so that we always use the private network. There's no TLS, super important, by the way. Varnish Cache, the open source one, doesn't support TLS termination, which means that you need an extra component to be able to connect to a backend which terminates TLS, which is where we got stuck the first time when we tried this with James. So yeah, don't terminate TLS with Varnish free. It won't work. You need extra tools. It gets a bit complicated. And then we have the response, which is what we configure, the VCL deliver, and this is like the cache status. By the way, this is all new as well in this pull request. So this is how we built that header. So how does it change the actual response? So flyctl apps list. Let's look at the changelog org, and let's look for all the CDN apps. This is the one that we want. And if I do http stat this app.fly.dev, obviously I want https, and let's see the response. So in this case, we have a 503. We see the cache status header, the edge, by the way, and this is interesting because we see where the edge is. We can see where the region is, so we can tell that this was searched from Ashburn, Virginia, and we are controlling all of that in VCL. How many? This was hits 0. This was a miss, right? A clean miss, and grace 0, TTL 0. Nothing can be set because this is unhealthy. And if you were to load this in the browser, right, which is what I'm going to do now, let me just open it in the browser. This is what it looks like. Right? It's like the varnish failure page. So this is where we are at. So why is this happening? Okay, flyctl SSH console, and we have the app. And actually, I am in the pipe dream, so I can just do flycch console. I don't need to specify an app name. It will put me in the app. And I have a tmux session running there. This is why this is happening. What's the problem here, Peter? How do you interpret that?
So because of the backend.
Mm-hmm.
So backend name changelog. So maybe with the app name, I think changelog -2024 0112.
Yeah. So this is the application instance. This is internal to Fly. It will be resolved via the internal DNS using it will be IPv6.
Yeah.
That's the port. We can see that that's getting resolved, right? We can confirm that this is like the first IPv6. We run 2 instances, by the way. So the application has 2 instances. There will be 2 backends, which is why I want the dynamic one so that we can basically round robin between them. And also when one gets deployed, we do blue green. If one was to fail, whatever, there's another one which is up and running. So the backend appears to be sick. And that's a problem, right? Because Varnish cannot connect to the application. However, if you were to do a curl request to the same application using internal, right, using the same port, using the health endpoint, we can see how it resolves the host name. And it does it resolve correctly? 88bb7 colon 2. 88bb7 colon 2. So this is it. This is the one that resolves to. So that is correct. And health endpoint, get health, host, HTTP 200 OK. There's no TLS. So this is a question. This is where we will be ending, Peter. And this is the question to the viewers, present or future. What is the problem here? What is the problem in this pull request, in this config, which changes import dynamic, in this changelog health probe? To me, everything looks correct.
But you said maybe it's expecting to terminate TLS. Oh, you said it doesn't use
it doesn't.
TLS.
I was just confirming. There's no TLS. There's nothing like that. So we can see that the host name gets resolved correctly. The path, we know it's correct. It is /health, so that is correct.
That's strange.
By the way, if we enable this, if we enable the resolver and the DNS, if we enable these 3 lines, it doesn't even resolve the DNS. So we know that this doesn't work. So if you have any ideas, this is a pull request to come and comment.
I think you shared the
I
link
did.
to the pull request earlier.
GitHub.com, changelog, pipe dream, pull request 1. So the dynamic backend, they don't work yet. I'll follow up on the Varnish forums, on the community forums, just to see what we're doing wrong, maybe on the Varnish GitHub repository. But this is where we are currently at. And this is how, if you want to help us, it'll be appreciated.
Yeah, I'll check it out if I've got time. I have no experience with Varnish. I've only looked at a different one, Apache Traffic Server, but maybe I'll find the time to also, just to look at how you guys are configuring the Varnish and how it's running.
Thank you, Peter. That will be appreciated.
Yeah. Any other points? I see we don't have any questions from the chat so far. Just comments. From my part, I think it's quite impressive to see the amount of speed, even just with 16 regions, running the Vanish server. It's quite impressive how much latency you can get with it, how fast it could be. Then I imagine what more can you do if you have more region, and also thinking what if one could build like a CDN, like just single purpose, just caching, no security, networking, no edge workers, we just deploy it for you and you pay us.
Yeah, I
Could
think
be
that's
a
a good
good
idea.
business
I
model.
think that's a good idea, but I think it's sharing this, I think, passion with others, the
Yeah,
curiosity, like demystifying some of the things, figuring some of the issues. We basically had to go through quite a few blockers to get to this point. And back to Jared's comment, I'm sure there will be a few others. Now, we don't have the resources to sink all the time that's needed into this ourselves. It
okay.
will take us a while, and we will get there eventually, but there's only so much that we can give this. If others are willing to help, it means we'll get there quicker. And for that, we're happy to share this. We're happy to make people part of this journey. I think that's what makes this exciting. We're talking about it openly. We're very honest about what is expected and what we're trying to do. And we share everything as we do it, as we go along. So now that I'm thinking back about like the latency and the variance in latency, we are using the smallest fly instance. One shared CPU and 256 megabytes of RAM. I think that shared CPU is why the latency is a bit variable. It is possible because also the networking, think about how many other Firecracker micro VMs are running on the same host. Once you get a bigger instance, you'll get priority on the network,
Yeah.
you'll get priority on the CPU. So I think the latency will be a lot more stable. This for now, it's mostly proof of concept, but I'm excited to see where we take it this year. Like in the next 6 months, I think this will be there, even with the little time that we have to dedicate to this. And even if like no one is maybe interested in helping, and that's fine. So we will get there eventually. And even if we get there slowly, it's not a problem. But if others are interested, I'm looking forward to hearing about you and seeing you in the GitHub pull requests via Peter's channel. And who knows, maybe we'll do a follow-up.
Yeah, hopefully we do a follow. And one question on the origin, do you happen to run maybe like a Caddy or traffic or something similar on one of?
Okay, so the origin itself is the Phoenix application. The Phoenix application runs in the Erlang VM, and the component which serves those requests is called Cowboy. Cowboy and Ranch, which are libraries in the Erlang ecosystem. Loic Hogwin, I'm giving a shout out to him. We used to work together on the RabbitMQ team. He's the author of those libraries. It's a really solid piece of tech which underpins most of the HTTP that happens and the TCP that happens in the Erlang world. Those are really reliable and solid components which Erlang, I mean, if you know the actor model and if you love the actor model and message passing everywhere, it's based off of that. In terms of the biggest successes of Erlang, public successes, I would call WhatsApp. WhatsApp
Oh,
runs all of it runs, or at least it used to. I don't think they've changed it, but it used to be one of the biggest Erlang successes.
and that's nice.
So yeah, that's what
I,
the
a-
origin is.
I asked because I was curious. I know from I have some guests in the next couple of weeks as well,
Hmm.
talking about how one also building a CDN service or like kind of like a Fastly competitor, and the other built a library for like a caching middleware. So if you use like Caddy server or Traffic
Hmm.
or a couple of other ones, so you can plug in
Yep.
the caching server middleware, I think, and it
Hmm.
would just do the caching. So I was curious if you use
Yep.
that, and maybe you can try it out and see how that
Yep.
works out for you.
Yep.
But um, are you guys at the changelog curious about trying something other than Vanish, or is just Vanish you want to stick to?
So the first thinking is we want to keep the delta as small as possible between what we currently run in production and this pipe dream configuration. So we have a lot of VCL, which is mostly managed by Fastly. And there's a lot of stuff there which is Fastly specific that we either can't use because it's Varnish Enterprise, plus like the secret like Varnish source, sorry, Fastly source, which you don't even know what it is, right? Because not just Varnish Enterprise, there's like other stuff on top of it. So from the initial production config, we will take a small slice. And the migration is going to be smaller because we can reuse pieces, right? We can reuse from that configuration language. Now, if Varnish was to not work, whatever the reason is, maybe the delta is too big between Varnish Enterprise and Varnish Open Source. We don't know yet. That's what we're exploring right now. That's what we're trying to figure out, especially with the IPv6. There might be something that we're missing, a vmod or something like that. So we would like to stick with this for a while longer because we would like to continue the same technology that has served us well all these years. Now, if this, let's say in 6 months' time, we don't get too far, then I think it'll be good time to reconsider and look into something else. What I would pick boring technology, to be honest. I mean, and it's in the DNAs, in the changelog DNA. We're using Postgres, and it served us really, really well. We're using the Erlang VM and the Phoenix framework for many, many years now, 2016, 8 years precisely. And again, it served us really well. So we'd like to stick with this because we know it. We're a small team. We have very little time to give to this. And while we do like experimenting, the experiments have to be time bound and they have to be just like a little bit better than before, a little bit better than before. So think Porsche, right? Like small improvements, same car, just a little bit better every year. So that's the game that we're playing. It's called Kaizen. It's wonderful. I highly recommend it. We talk about it every 2.5 months, by the way. So, and
Yeah.
we've been doing this for some number of years now.
Uh, yeah. Then uh, good luck with it. I would
Thank you.
also try to find time to do. We'll be
Yeah.
wrapping up now so that we can both go about our day. Any other thing you want to? I know you in the beginning you blogged, you mentioned the changelog and your website so
Mhm.
people can check you out.
Mhm.
Any other thing you want to mention about yourself or your work, or maybe recommend a book on for people on Elixir or CDN and caching or performance?
So, the last thing which I would say is that my passion, for as long as I can remember, has been infrastructure. I love infrastructure, which is what got me close to the changelog team. That's how I got to know them, and that's how we continue that. This is what I do. I would say maybe 5% of my time, and this is my free time. My main job and my main activity is my main role. No, let me rephrase that. Uh, the the thing which I do the most is make Dagger.io
Hmm.
be the new CI/CD system of choice. I think CI/CD is long overdue an overhaul. Like the whole thing, like the complexity around GitHub Actions, around Jenkins, around Circle CI, all that YAML all those like vendor lock-ins, I believe that they should disappear. I believe that you should be able to run CI/CD locally. Very important. Exactly as it runs in production. No difference. And you're familiar with this concept because Docker was the first one to introduce it with containers. You should be able to run exactly the same artifact that will run in production, and then you ship that in production. And I know the meme, right? You ship development in production. We had good fun. But the point is, you want fast feedback loops, you want that reproducibility, and you want components that you share with others in an open source way when it comes to CI/CD, when it comes to automation. So I'm big on Dagger. I think you should go and check it out if you haven't already. And I think in the context of CDNs, they are important because there's a lot of layers that are being shipped around. But there's something more about caching. So I think the CDNs are going in a very interesting direction right now with the rise of WASM and WASI. And there's a technology which I'm excited about that bridges these gaps. That's what it is. I can see that being a future even beyond containers. Now, I haven't spent too much time with it myself, but it's been up and coming over the years. I've been following it like from a distance, from afar, and I think I'm getting ready to jump in. So, with that thinking, is could we use that in the context of CDNs and more? Like a technology that will underpin the future systems, regardless whether it's a CDN, whether it's CI/CD, whether it's something else. So that's I think the last thought that I would like us to leave us on. But thank you very much, Peter, for the question, and thank you very much for today. I had an amazing time, and I'm looking forward to the next one.
Yeah, my pleasure. Everyone, have a nice day. Bye.
See you, everyone.